Okay, welcome to lesson 5 of pre-calculus. In this video, we're going to be talking about partial sums of arithmetic sequences. And so I want to just emphasize that this is only for one type of sequence, only the kind where we're adding or subtracting to get from term to term. This will not work for geometric sequences. So make sure that you explicitly say or distinguish this from the next lesson where we'll talk about geometric sequences. So this is just a general definition, and this will apply for both arithmetic and geometric sequences. So when I'm taking a partial sum, this means that I'm going to take the sum of the first k terms in a sequence, where k is some number or some ending term number, or where I've got an endpoint to what I'm adding together. So let's look really quickly at some sequence notation and what this definition actually means. Okay, so here's our sequence notation, and I recognize that this kind of has a lot going on. What this says, so this symbol over here where you've got a K and some weird Greek letter and n equals 1 of u sub n, this is saying to take the sum of the sequence in u sub n, starting at the first term and going to the kth term, where k, u sub k, is your endpoint. So I'm adding together what's the first term plus the second term plus the third term plus the fourth term plus the fifth term until I get to whatever k is. And k is some variable. It'll always be a number. So you know what number you're ending at. And so I'm going to put just some words to this notation. This says when you've got this big Greek letter. So this big Greek letter is called sigma. And what it means, or what it's telling you to do, similar to an addition sign or a minus sign, this is telling you to take the sum of a bunch of numbers, of many numbers. So where an addition sign just tells you to add two numbers together, your sigma sign tells you to add together a lot of numbers. This bottom number is always going to be your starting term number. So for example, this would tell me to start with u sub 1. This would tell me to start with u sub 1. Versus your top number tells you the ending term number. So this tells me, my ending term number. So this tells me to end with u sub k. And then lastly, u sub n is just the equation for my sequence. U sub n is the equation for my sequence. Okay, so we're going to do an example of this in just a moment. First, there are a couple formulas that you just need to know. So this over here is what the questions will look like, or how you want to set up your questions. And let's look at how to solve them. So we've got two formulas up here, and you're going to use them in different scenarios. So if you know what the kth term is, you know what u sub k is equal to, and this number will be different from what k is equal to. These two numbers will, for the most part, unless you've got a weird sequence, these two numbers will be different from each other. If you know the kth term, you're going to plug your values into this formula. So whatever k is, and this will be a number, not a variable, divided by 2, plus your first term, times your first term plus your last term. If you don't know the kth term, and that's okay, sometimes you won't, you're always going to know what k is, and you should be able to figure out what u sub 1 is. If you don't know the kth term, you're going to take k times u sub 1 plus, and then this whole thing is a fraction. So you've got k times k minus 1, and again, k will be some number, times your difference, and you're going to take that whole product and divide it by 2. So let's look at an example. Please make sure you get these two formulas down. They are important to know and distinguish between when you're going to use them. So if you know the kth term, you're going to use this formula. If you don't know the kth term, you're going to use the second one. Okay, let's look at some examples. So let's say my instructions are to find the 12th partial sum of this sequence. U sub n is equal to -8 plus n minus 1 minus 5. And you may notice that I've given this to you in the explicit form. So this is the explicit formula for an arithmetic sequence. And I know that because there are no exponents in this whole equation. So the nice thing about giving you the u sub n in terms of, or in the explicit form, is that you already know a couple things. I know that in my explicit form, my first value, so in this case -8, is my u sub 1. I also know that this 5 over here is my difference. Okay, so I know two things so far. Let's look back at the question. Find the 12th partial sum of the sequence. When I see this 12 here, so 12th partial sum, that 12 is telling me the term to end on. So my last term, or my term number, is going to be 12. So k is equal to 12. So these are the things that I know. My first term is -8, my difference is 5, and the sum that I'm adding to is the 12th term, or the last term that I'm adding to is the 12th term. That's going to equal k. So let's look back at those formulas. Which formula do I have enough information to use? And I'll post the problem up as well. Information that I have up here, along with these two formulas, which formula can I use off the bat? According to the information that I know, so I do not know what the kth term is. I know what k equals, which goes into both of these equations, and I also know the difference. So this is looking like an ideal formula to use. So I'm going to use my second formula. What I'm going to do now, just so that I can reference it, I'm going to copy that second formula down on my sheet. So I know the sum from n equals 1. So for all of these problems, you're going to set n equal to 1, so you're always going to start with that first term. 2, in this case, k is equal to 12, is equal to, so now I've got k times u sub 1 plus k times k minus 1 times the difference over 2. And let's keep solving this problem. Okay, so now I'm going to substitute everything in. So my sum is equal to, k is equal to 12, times my u sub 1 I know is -8, plus, and now I've got a bunch of k's, so 12 times 12 minus 1 times my difference, which is going to be 5, all over 2. When I solve this, I'm going to use the order of operations to simplify, and I'll go through this a little bit quickly. So my sum is equal to, I'm going to leave 12 times -8, plus 12 times 12 minus 1 is going to give me 11 times 5 divided by 2. While you're solving this, you're more than welcome to use your calculator. I'm going to go grab mine, and we're going to type this all in. So I'm going to have 12 times negative 8 plus, and then this is how you're going to enter it into your graphing calculator. If you're working on a non-graphing calculator, that's okay. Just know that I'll make you practice with this tomorrow. So in parentheses, I'm going to take my whole numerator to my fraction. So 12 times 11 times 5. And then I'm going to close those parentheses and divide that by 2. And let's see what I get out. So my total sum, and this is just my final answer, my final sum is going to be 234. So my sum equals 234. And that is taking, this is equal to my first term plus my second term plus my third term plus my fourth term all the way up to my 12th term. And that's what this value represents. You're going to solve a very, very similar problem. I want you to find the 14th partial sum of the sequence u sub n equals 21 plus n minus 1 times 6. I'm giving you the formula in a very similar way to what I did up here. You could follow the same exact steps down. You just have to figure out what is k, what is u sub 1, what is your difference. Go ahead. Okay, so here's your next piece. So sometimes I will not give you your sequence in the explicit form like I did with this problem and with the problem before that. In which case you need to figure out, is my equation arithmetic versus geometric? You need to figure out, what am I doing to go from term to term? So I want to give you an example of a sequence that is arithmetic, even though it might not seem like it. So what if I gave you the equation, and I'll change this for just 1 second, u sub n is equal to 2x minus 2. Well, I don't know about this equation, but I do know, 2n minus 2. But I do know something about this equation where I just replaced my n with x and replaced u sub n with y. And so this is just to give you an example. You normally wouldn't really do this. So if I were to graph this line, y equals 2x minus 2, my y-intercept is at -2, and I'm rising 2, running 1 to get from point to point. So I'm going to connect these points in a line. If I were to list out my points to this line in a table, so at -1, my y value is -4. At 0, my y value is -2. At 1, my y value is 0. And at 2, my y value is 2. At 3, my y value is 4. Take a moment and identify, what am I doing to get from term to term in these y values? Great, you should have figured out that I'm adding 2 to get from term to term. And this is because this is a linear equation. My slope stays exactly the same from point to point. Whenever you have a linear equation, like this one, to find your terms, so u sub n equals 2 times n minus 2, that looks like a linear equation. I could identify a slope, and I could identify a y-intercept. If it's a linear equation, so there are no exponents, then I've got an arithmetic sequence. And we'll talk a little bit later about how to identify geometric sequences. Let's look at an example where I'm giving you u sub n like this. So if I wanted you to find the 8th partial sum of u sub n is equal to 3n minus 6. So in this case, 8th partial sum, what does that tell me? Great, that tells me k equals 8. And so in this case, if I go back to those formulas, I don't really know, right now I don't know u sub 1, I don't know the difference, I also don't know what u sub k is. However, I could very easily find u sub 1 and u sub k, where k equals 8. So really this is u sub 8. How do I, in your own words, how do I find u sub 1 using this equation? Great, so if I'm replacing n with 1 over here, I can just replace n with 1 over here. So this is 3 times 1 minus 6. U sub 1 will equal 3 minus 6, or u sub 1 equals negative 3. Okay, now I've got my first term. I can do the same thing with u sub 8 over here. If I replaced 8 with n over here, I'm going to do the same over with this 8. Go ahead and find u sub 8 on your own. Great. You should end up with u sub 8 is equal to 18. So now, based on the information I have up here, and I'll make this a little bit small again on this formula, but based on this information, which formula could I use? Could I use this top one or the bottom one? So I know what k is, I know what u sub 1 is, I know what u sub k is. It's my 8th term. So in this instance, I'm actually going to use my top formula, and I'm going to go ahead and copy that down right below. So my sum is equal to k over 2 times u sub 1 plus u sub k. And let's go ahead and plug in what we know. Okay, so I know that k is equal to 8. Notice that 8 and u sub 8 are not the same values. I'm going to substitute in different things for k and u sub k. So my sum is equal to 8 over 2 times my first term, so that's a negative 3, plus my kth term. So not 8, but 18. And I'm going to go ahead and simplify that in my calculator. So I know negative 3 plus 18. So I've got 8 over 2 times 15. And then if I simplify 8 over 2, I'll get 4 times 15. And 4 times 15, that's going to equal 60. So 60 is what I get when I add together the first 8 terms in this sequence. Okay, another really similar problem. Take a look at this. I'm giving you the same information. You're finding the 6th partial sum of this sequence. Go ahead.